Hello everyone. In this lesson, we will use Laplace transform to solve for second-order differential equation. Before we solve for this second-order differential equation, I would like to remind everyone that we are going to use a very important property of Laplace transform. So Laplace of y double prime will be equal to s squared times Laplace of y, subtract s, times y evaluate at the value equal to 0, subtract y prime evaluate at the value equal to 0. So keep this in mind. This is a very important property for us to use in solving for second order differential equation. So let's start with the step of take Laplace transform on both sides of the equation. So I take Laplace transform of 9y double prime plus 4y equal to Laplace of 2t. So taking Laplace transform of this expression, I can break it into individual Laplace transform of each term. At the same time, I will take 9 and I multiply by Laplace of y double prime and 4 times Laplace of y equal to Laplace of t, and I can bring 2 across the Laplace transform sign. So the next step is to use this important property, okay, and apply to this Laplace of double prime. So I will write 9 multiplied by s squared Laplace of y, subtract s times y of 0, and subtract y prime of 0, plus 4 Laplace of y times 2 Laplace of t. Okay, so let's simplify this. So this is equal to 0. This is also equal to 0. So on the left-hand side of the equation, I am left with 9s squared Laplace of y plus 4 Laplace of y. Okay, so at this point, I would like everyone to perform this operation. So we are going to take Laplace of t. It means we are going to transform this function of t into a function in terms of s. Okay, so in order for us to do that, what I will do is I will write t to the exponent 1. Okay, writing to the exponent 1, I can compare with my Laplace transform table to see which one that I can use. So in this case, you see that I can use Laplace transform number 2. So with t to the exponent n, in this case n is equal to 1, I will have n factorial divided by s n plus 1. So let's write it down on our questions here. So we are going to use transform number 2. Okay, given n is equal to 1, so I should have this as 1 factorial divided by s of 1 plus 1. So therefore it will equal to 1 over s squared, and I multiply this by 2. Okay. The next step is to factor out Ly. So factor out Ly, I am left with 9s squared plus 4 inside the bracket. On the other side, I would like to write 2 over s squared. Now again, I will isolate Ly. Okay, so it will be 2 over s squared divided by, again I will write it as 9s squared plus 4 over 1. Then this will turn into multiplication of 1 over 9s squared plus 4. Okay, so let's put it together as 2 over s squared multiply 9s squared plus 4. So at this point, what we need to do is we need to examine this expression and try to figure out what transform we are going to use so that we can transform this into a function in terms of t. So before we get into our Laplace transform table, I would like you to note that you have s squared, you have s squared in the bracket. So let's find a transform that's similar to that. Alright, so I go over here. So let's take a look at a few of them. Okay, so this one I have s, but I don't have s on my expression. Here I have a. Okay, here I have a squared. So very close, but I have s multiplied by s squared, so this one I cannot use. I have s squared and s squared, so I'm going to use transform number 8. Okay, so let's write down transform number 8. So I will use transform number 8. Okay, using transform number 8, I need to have this as a perfect square of a. Okay, and then I also noticed that I have a 9 in here, but transform number 8 said that I should use just a3, right? A to the exponent 3 divided by s squared times s squared plus a squared. So you need to get rid of the number 9. So how do we get rid of number 9? One way to do that is to factor out the 9. Okay, so let's rewrite this. Ly equal to 2 over 9s squared. So inside the bracket, I should left with 9s squared divided by 9 plus 4 over 9. So this one and this one cancel out. I should have 2 over 9s squared. Inside the bracket, I can write s squared plus 2 squared over 3 squared. Why do I write 2 squared over 3 squared? Because I need this a squared over here. So from here, I can figure out that if 2 squared divided by 3 squared equal to a squared, then a is equal to 2 over 3. Okay, so from this you can find a to the exponent 3. So you can have a to the exponent 3, so you raise this to exponent 3, raise this to exponent 3. I should have 8 over 27. Okay, so keep that in mind. A cubed equal to 8 over 27. So let's see what we have. So Laplace of y will be equal to, alright, okay, I will write 2 over 9s squared, okay. As a denominator inside this bracket, I should have 8 over 27 divided by s squared plus 2 over 3, all of it squared. Since I multiply this numerator by 8 over 27, then I should divide it by 8 over 27 here. So that means I multiply by 1 over 8 over 27. Okay, so let's simplify all the number. So we have 9, not 9, it's actually 2. Okay, 2 over 9s squared multiplied by 27 over 8. Okay, and this I still have 8 over 27 divided by s squared plus 2 over 3, all of it squared in the brackets. Simplify all of this number. I should have here 3. I should have here 4. Okay, the next step is we should perform the Laplace inverse of the function fs so that we can pull out our y or our f of t. Okay, so we should have 3/4 left over. Okay, and in here the s square go there, right? So with this s square, I can convert that into my Laplace in term of t. So it will be at minus sine of at, which is transform number 8. So I can write this as multiplied by 2/3 t subtract sine 2/3 t close the bracket, and we are done.